title for Arif with you.
Thank you very much, Tom. And yeah, thanks for being here. It seems I have the honor of kind of closing this fantastic data mesh only conference. So let's get into this. As said, the title of my talk is Automating Federated Data Governance with Sharer-Driven Data Contracts, so a specific type of data contracts that we'll look into. Few words about myself. So my name is Arif wieder. I used to work full-time for ThoughtWorks, the company where data mesh was invented by Jean-Marc Dercani, and I was at some point the head of data and AI for ThoughtWorks Germany, and that was exactly at the time when Jean-Marc was mainly in the US branch of ThoughtWorks, or was mainly working in the US, and came up with her first draft of this first article somewhere in 2019. And as I was in this position in Germany, I was very early on that I saw this draft and was able to give feedback, etc. Right, and so that means I was very early in contact with that, and honestly, pretty much since then, because data mesh was or became such a hype, I have pretty much exclusively done data mesh as a topic, at least for my industry work. That is to say, about 5 years ago, I sort of quit industry and moved back to academia, and I'm a full-time professor at a Berlin-based university since then, teaching mostly programming and software engineering. And but I do continue to work in industry, both with ThoughtWorks and as an independent consultant, because I really enjoy working with companies on data mesh, mostly on the strategic side, etc. Right? And being here sort of at DDD Europe conference, I also want to share a story that kind of started the whole thing really for me, which was a DDD conference in early 2020, which was happening in Amsterdam, and nobody knew what was still to come in 2020. And I got a message from Jean-Marc in the ThoughtWorks internal chat, and she told me, yeah, I'm speaking at this DD Europe conference, but I can't make it. Can you jump in? And by the way, this is day after tomorrow. And I was like, okay, sure, why not? And then a couple of days later, I was in Amsterdam at DD Europe, and giving basically one of the first talks about data mesh, and I think it might have been the first talk about data mesh that was not from Jean-Marc herself, and that kind of jump started me into that thing, and since then, as said, I think I've only given talks about data mesh since then. So it's really cool to be back for that occasion of having a data mesh only conference here. All right, I just said this before that because we are at a data mesh only conference here, it's actually super exciting that for a change, I don't have to start at the beginning, right? Because that's what I'm used to, is that I always have to start at the very beginning. Nevertheless, I want to give at least my personal perspective on what I think is the key innovation and also the key motivation of data mesh, right? And we all know, probably most of you here in the room know what data mesh is, when it came about, etc. And we have even seen in a previous talk today pretty much exactly that plot here, but I think it still summarizes very nicely what data mesh is about, right? What problem we want to solve. We want to solve the problem of the data source, of the scale of data sources and the growth of data and data use cases. We want to avoid with scaling this up on this axis, that the business impact is actually not increasing, but instead is falling down again, right? And this is not something theoretical. This is something that I have myself seen and experienced personally several times, right? Because as said, I worked as a consultant, and that means I was always going into companies, helping the data teams, the central data teams, the just product teams, building applications that needed data, managing projects, etc., right? And there's really this situation that back at the time I saw again and again, and unfortunately I still see it today sometimes, and that is the following. So we have the data producers here on the left as kind of a role, and those are the people who build the production systems, generate data as sort of a byproduct, and they are kind of happy, and they have, let's say, their own problems, but when it comes to data, they don't really feel any pain about data quality, etc. And then we have the data consumers on the other side, and of course they are the ones who have to make some sense out of the data, which means they do feel the pain when the data is of poor quality, if it's not well documented, etc., right? But then what I saw so often is that we have this group in the middle, which is the team that builds the central data platform, and they are actually in an even worse spot, because they are the ones who have to firefight all day to fix issues that have been introduced upstream by the data producers. At the same time, they have to listen to the complaints coming from the data consumers, right? And to make things even worse, those folks in the central data team, they cannot even solve the issues themselves, because often those issues originate upstream, which means they have to go to the data producers and ask them to change something so that that the problem gets fixed. And they often do not even build the nice data use cases that are built by the data consumers, right? And this is a very bad situation that really led to the point where often basically everything came to a halt, right? So this graph from before, I really saw the point where this went basically here. And then nothing was working anymore, because the central team was just so overloaded that everyone was annoyed at them, and they were miserable, and it was all really bad, right? And it's exactly such situations that I want to avoid in the future, right? And I know from Jean-Marc that she was also very emotionally motivated. She was, as she said herself, angry at the situation at the time, right? That we have situations like this, and that we actually have solutions or approaches from the general software engineering domain that we could apply to avoid such situations, but we don't, right? And that really made her to write this first article, as she said herself, in a bit of a angry rant mode, and then she wrote it up very nicely, and that's how all of this came to be. Now, what is my take on why we see this problem happening again and again when we do not apply data mesh. If we imagine a company with a central data platform, and with central I mean a data platform with central data ownership, and let's say we have lots of data sources here on the left and lots of data consumption use cases on the right. And let's say this is an e-commerce company. I have most of my industry experience with e-commerce companies or companies that have an e-commerce part to them. And pretty much every of those companies has a checkout service, right? So a service that runs the checkout system, and whenever people or customers go to the checkout and buy something, then a checkout event gets created, and this checkout event in such a centralized data ownership structure then ends up in the central data platform. And what has happened now is that we have this domain of checkouts. We're sort of at DDD after all, right? We have this domain of checkouts. That means what is a checkout? When did how many checkouts happen? What can you do with a checkout, etc., right? So all this knowledge about checkouts. We have this domain being cut in half by ownership boundaries, right? Because what we have now is that the checkout events, they fall under the ownership of the people maintaining the central data platform, but the knowledge about what a checkout event is, how it is generated, etc., that is living in the team that maintains the checkout service. And this is, well, how you don't do DDD, right? When you really have those domains being scattered across teams. And that creates friction and inefficiencies and misunderstandings. And this friction, if you have a company where both this side and this side is growing rapidly, this friction adds up, and in the worst case adds up so much that we reach this halt, right, where nothing works anymore with a centralized setup. And this is really what we want to solve with data mesh, to get away from this. And to me, the key innovation of data mesh is that this is solved by shifting the ownership to where the expertise is, right, which is core domain-driven design. Now, almost certainly most of you sitting here in the room know the 4 principles of data mesh. This is how data mesh does this. And I want to mostly focus on the federated computational governance part today, because this is what my contribution of this talk is about, but also because I feel that this side for a while had been overlooked a little bit, right? I feel in the original first article by Jean-Marc, it was barely mentioned, and then it was more detailed in the second article on martinfowler.com. And then, of course, in her book, it was more detailed out, but even there, I would say it was still very, very vague, right? And in contrast to this, being slightly neglected, when I was working with clients, a majority of the questions that I got were often about federated computational governance, right? And so that created a bit of a contrast that that motivated to work even more in this field and maybe get rid a bit of this vagueness. So I can skip a bit over those general principles, how data mesh works, which is by creating data products, structuring your data landscape in domains, having domain teams take full end-to-end ownership, for those data products. And this is the part where I don't want to skip too much over, those teams being enabled and supported by the self-service data infrastructure platform, right? Because in the end, with this shift left, which I will talk in a minute about, or with this ownership shift, we put a lot of responsibilities and work on the shoulders of the data owners, right? And this is one of the most common mistakes that I have seen with data mesh adoption in industry, is that you just bury the data owners in responsibilities and work, right? And then they may have the best intentions, but they are simply not able to do their job anymore and fulfill this responsibility. And this is why the whole data mesh idea simply doesn't work without this self-service infrastructure platform that really provides tools that are so good that the data owners can focus on their expertise, which is their knowledge about the data, and do not have to deal with complicated details of the data infrastructure, etc. Right? And this is really the key thing that is very important that this data infrastructure delivers. And honestly, there are not too many tools around right now that deliver on that promise. So moving back specifically to data governance, with data governance, Jean-Marc coined the term computational data governance, right? So what does that mean? It means that we not only want to enable the data owners so that they don't have to know all the details about data infrastructure, but we also want to automate as much as possible, right? The idea is that this same data infrastructure platform, or let's call it a data mesh platform simply, should also automate as much as possible. And we have seen already several talks today about various parts of this. Kiran in the morning mentioned the fitness functions, yeah, we have seen different parts of this before, and we have seen talks about contracts and SLOs, etc. In general, what do we mean with this federated governance? Of course, the team needs to be federated, but where the federation happens is that the governance team is not, the now federated governance team is not responsible anymore, for instance, for the data quality, but instead it is responsible for defining what constitutes data quality, right? Or to take an example, which I like to take often, the federated governance team is not responsible anymore for data protection, but it is responsible for defining, for instance, sensitivity levels and defining corresponding global policies. Let's say you have a global policy saying all PII data needs to be encrypted, and then they need to work together with the data mesh platform or the data mesh platform team so that the data owners can tag their data correctly, and then using the sensitivity levels that have been provided by the global governance team, and then the data mesh platform can ideally automatically check whether those global policies are adhered to or not. And I choose this focus of computational governance, as I said before, because I felt it was partly overlooked or simply not there yet, right? And this is why on my academic side, I started to focus on this in my research. And I started with this paper here, which was 2 years ago, with colleagues from ThoughtWorks, where we started to basically sketch out the concepts of what is what does such a data mesh platform need to provide to enable this federated computational data governance. And then with even more colleagues at the time at ThoughtWorks, we moved further or deeper into data protection topics and sketched a concept of how we can check whether such data protection attributes can be automatically checked, which is what I will look into in a minute. And this year, I have even two papers. This one has just been accepted, and that was the talk that I gave together with Simon half an hour ago, where we use AI to do this governance automation as part of a data mesh platform. And then I have another paper coming up that is about moving this now from within one company to inter-organizational data sharing. But that's not the topic of this talk now. So let's come back to this example that I just talked about of what computational data governance is. And I illustrate exactly that example that I just outlined. So we have the central or the federated governance team up here, because even if it's federated governance, we still need a governance team, right? And that is central, right? And now with this federated computational governance, the job of that central governance team is to define those global sensitivity levels, to take that example. And the teams that build and maintain those data products can then use tools provided by the data mesh platform that allow them to tag their data correctly using those globally defined sensitivity levels, right? So this is the one thing. The data mesh platform provides the tools to make it easy to the data owners to contribute their expertise, basically. But then we want to do more when we want to do computational governance, which is we want to monitor and verify as much as possible about, for instance, data protection issues, right? And this is where almost naturally data contracts come into the view, because data contracts allow us to explicitly state constraints and SLOs, etc., right? And so what we want to have is we want to have a contract here between the output port of a sharing data product and the input port of a consuming data product. And basically where we want to go with this is that we can start to reason and to automate the relationship between two data products. And then when we can guarantee the properties of the interaction between two data products, then of course we can go one hop further and transitively can monitor and ensure the correctness of the entire data mesh, right? That's where we want to go to. Honestly, this is not where we are yet. Now, I want to focus on this part here now, right? On this thing that we have two data products interacting with each other, and we have a contract between them, and we want to help with automation to show whether this contract holds or not, right? And this specific problem is something that we have actually seen before, right? And I haven't mentioned this now. My background is in software engineering. This is where I come from. And also, as said before, this is what drove Zhamak to go into the data field, is that she came from the software engineering side of things and was angry that those solutions that were already there in systems engineering were not applied on the data side of things. And here is kind of the similar problem that we have very often and for a long time already in microservices is when we have two services that depend on each other, or where at least one depends on the other. A very simple example, we have one web application that has its own CI/CD pipeline, and let's say this is an application that depends on a machine learning model or an AI model, and this has its own CI/CD pipeline with a model training, etc. And in the end, what we have is we have here a staging environment. So the web application is deployed to the staging environment, and the model service is also deployed to a staging environment, and we have a production environment, right? And in between here, we have load tests, etc., to ensure that everything is going well, right? Now, already with moving to microservices, we had the issue here now that when you deploy a new version of the web application, you need to make sure, or let's put it the other way around, when you deploy a new version of the model, you want to make sure that the current version of the web application that is running here is still working with the new version of the model that is coming up, right? But you also want to check the other way around. If you deploy a new version of the web application, you want to make sure that it's still working with the old version of the model service. Well, the problem is now when you only have it this rigidly, then you need to have to do things like a lockstep release, where you basically have to deploy new versions of both things at the same time to make sure that they really work together, right? And to avoid things like this, you would need to basically cross-check the newest version in production from the one service with the old version in the that is still in staging, and vice versa. Otherwise, you always have to coordinate when new versions get released, etc. Right? And only this way you get flexibility that you don't have to coordinate when some team is allowed to push a new version into production. And this is a problem that already occurred 10, 15 years ago. And there is a nice approach to solve this, and a former colleague of mine, Ham, wrote a nice article also on martinfowler.com about this in 2018, and that is about consumer-driven contract testing. So this so far has nothing to do with data mesh. But it's exactly that situation that I outlined with data products or coupled data products, where there's service A that consumes an interface from service B, and we want to make sure that this is holding, right? And nothing goes wrong here when we deploy new versions of those services. And the idea of consumer-driven contract testing is now that the consumer, that's why it's called consumer-driven, is writing and publishing executable tests that describe their requirements and their expectations towards the provider, right? So they say we need this and this in this format, etc. And those executable tests are then executed in the CI/CD pipeline of the provider, which means, especially when such a provider has several consumers, let's say 10, it collects all the 10 consumer-driven contract tests in its own CI/CD pipeline, and then when a new version is to be deployed, then all those executable tests are run, and if any of those fail, then the providing service knows that it broke one of its consumers, right, and should consider not going into production. And this is exactly what I thought, well, why not use this for data mesh as well, where we have a very similar situation. So let's look again how this looks for microservices. We have the providing microservices that where the API is used by consuming microservice. We have SLOs here, for instance, being published by the providing microservice, and then we have here, for instance, an API test that is published by the consuming microservice, and of course they should match, but more importantly, they should not only match, they must match, and that is ensured by the platform, in this case the microservices infrastructure platform, which should provide some kind of CI/CD automation, and then the CI/CD platform or tooling can execute all those consumer-driven contract tests. Right? Now when we switch to data products, this looks very similar. We have a sharing data product, an output port, we have SLOs. Now it's a data test, and we have a consuming data product, and we have a data mesh platform here that can execute those consumer-driven data tests. And so we can basically do pretty much exactly the same as we did for microservices. It is a bit more complicated because data tests are actually complicated in itself, right? It's, I mean, at least if you get more complex, it's not that black and white at all times, but we also have by now quite a few tools for this with libraries like Great Expectations, DQ, etc., where we can also write good data tests here, right? So this is generally not, well, that's pretty doable. But as I said before, I'm really also interested in the topic of data protection. And when we deal with sensitive data, consumer-driven tests, as I just outlined them, are actually not enough. So if you consider a very typical situation, in fact, I cannot count how often I have built something like this with a client, where you have some kind of web tracking system and you have a team that builds a customer behavior data product or a service, and then we try to make it a data product. And that data from that customer behavior data product is used by a data product or a team that builds product recommendations, right? And naturally, the data that comes in here from that web tracking system that has a high sensitivity, this is this label here, right? It's very sensitive data of this user behavior. And this data is then shared with the team that builds those product recommendations. And so the data that is being shared is still very high. But what we ideally want to do is that then this team building the product recommendations is not resharing highly sensitive data anymore, right? Because those recommendations in itself are not highly sensitive data. And so what we want to do here is called a declassification, right? So it's classified data, and we want to say here, we receive classified data, but we declassify it by not sharing it in that detailed level, right? And it's those situations that we, again, want to support from the platform side of things, but which we cannot do with this model of consumer-driven contract tests. Because what we have now is that we do not only have requirements from the consumer to the provider, like how fresh the data has to be, about the quality, etc., but we also have now constraints from the provider of the data to the consumer or towards the consumer. Because this team here, they share highly sensitive data with the team building their product recommendations. And when something goes wrong and this data leaks or whatever, then it will eventually fall back on that team and they will be shouted at. Probably everyone will be shouted at. But that means ideally we want to have a way, or this team A wants to have a way to say we can only share this data with you if you promise to not reshare it in its sensitive form, right? Or if you reshare it in a sensitive form, then you have to do those things to make sure it's still protected, right? And this is where kind of now a new variant of those consumer-driven contract tests come in, which I called sharer-driven contract tests. So here up there we see the consumer-driven side of things, and down here we see the sharer-driven side of the data contract, or part of the data contract. And here it is now the sharing data product that states expectations, saying this is what we expect you to do with the data and what to not do and how to handle the data. And on the other side, on the consuming side, we have now assertions, so or promises. So the consuming data product now promises to do certain things. And those expectations and assertions now have to match. And specifically those assertions here, they usually reference both the input port and the output port of this data product, because, for instance, they assure that this particular data that they receive on this input port from that output port of that data is not being reshared on that output port, for instance, right? And they could have many output ports, and then you could say, we only reshare this sensitive data that we receive here on one of the output ports that is anonymized, right? Things like this. This is why you see here this connection. So here are a couple of examples how this could look like, that you basically say, so those are those expectations, right? You say, we expect that, oh no, this is the assertion, which references the input port B and the output port C, so this is this here. And we assert that we do a classification, a declassification, and we even provide a verification method, right? Because we still have the goal of doing automation here, right? We still want to make sure this can be, that we can automatically check this. And here we have the expectation, or an example for expectation, where we can say, we expect that, or we set certain constraints and say on the output port A here, we share data that has a high sensitivity, and we have a usage requirement and that is that differential privacy is applied when using this data, which is a very strong requirement, and we even provide a way how to measure that and how to verify this. In this case, even by saying you have to use this particular library to measure whether you whether this requirement holds. Right? Those are just examples how this could look like. And in this way, we get to a situation where we have those sharer-driven contracts, or actually just data contracts that have a sharer-driven and a consumer-driven part to them. And we have those constraints and those promises that are part of this or that are published respectively. And now we have or we need the data mesh platform to provide contract verification capabilities. So for instance, having here a constraint verification library that basically says I am able to check those categories of assertions, right? And then the constraint here on this side has to be needs to use those kinds of constraints that the mesh platform can also verify. And the other side is that the promises also need to be stated in such a way that it only uses attributes that can be verified, right? Which is honestly very complicated, and this is nothing that is implemented and fully working in that form. In fact, the work that we did or that I did with Simon, which we just presented in a talk before, might even be a bit more of a pragmatic approach about this, because there we use AI or generative AI to look at natural language text, right? So this has to be less formalized here, the constraints and the promises, but nevertheless, this is still a capability of the data mesh platform that we want to have, that the data mesh platform can say, I am able, for instance, to check these kinds of constraints being stated by a sharing data product, right? And this way, we can really make sure that we do not only monitor the requirements from consumers, but we also monitor whether the constraints being stated by sharing data products are being adhered to. And with that, I come to the summary of this talk, which is that the concept of consumer-driven contract testing, which comes from the microservices world, so to say, can be applied pretty much one-to-one to data products. But when dealing with sensitive data, or at the latest at this point, it's just not enough to only have this one side, right? But we also need the other direction, that providing data products can state constraints, local constraints specifically, in addition to maybe global policies and global constraints. And in order to be able to help with automation here, a data mesh platform needs to state what verification capabilities it can provide, right? So it needs to state, I am able to automatically verify this category of constraints, and if you formulate those constraints, then the data mesh platform will be able to help you monitor the compliance and correctness of the entire system. And with that, I thank you very much, and I'm more than happy to answer some questions.